guys, it's Miss Maneely, and I'm going to give you a quick tutorial on how to change from radians to degrees and from degrees to radians. I'm also going to show you how to find the arc length of a sector, or from a circle. So I'm going to jump right into just discussing the difference between a radian and a degree measure. When we measure angles, there's two different perspectives that we can take. So for example, the activity that you see on the board right now is an activity we did in class where I stood in front of the classroom, so pretend this is me, and then I had another student at the back of the classroom, and what I had them do is I had them walk. I had them walk across, and I had students look at my face, so basically I maintained eye contact with the student who was walking, and so as the student walked across the back of the classroom, my head tilted as they walked across the back of the classroom. So what I tried to relate was the tilt of my head would correspond to how we would measure the degree in degrees of an angle, and the distance that the student traveled is how we would measure radians. And so we're both measuring the same distance, we're just doing it from two different perspectives. And so any angle can be measured in degrees or radians. Radians I know you're not as familiar with because in geometry you dealt with degrees, but radians correspond to the circumference of a circle. And so every circle basically has 2 pi radians in it if we look at the entire distance around. So what does that mean? So you have some notes. I'm going to go through them real fast just so you understand the terminology, and then I'm going to show you how to relate degrees and radians together. So an angle basically is a measure of rotation. Angles are often measured in degrees. That's what you're most familiar with, which measure the direction and the angle size. So direction may not be something that you're familiar with. I think probably all of the degrees that you've seen are all positive, but it's possible for an angle to be like a negative 30 degrees, and it has to do with direction of our rotation. We know that one complete rotation, so if I basically start with a ray, and I do one complete rotation all the way around, I know that the total measure of that rotation is going to correspond to 360 degrees. It's a circle. Angle measures can be positive or negative, depending on the direction of the rotation. The angle measure is the amount of rotation between 2 rays that form the angle. So if you take a look, actually let me go ahead and erase this so I can take a look at these examples. So if we take a look at the 2 examples here, this side is what I would call my initial side. When my initial side is on the x-axis, we also say that it's in standard position. And all of the angles we're going to be looking at are going to be in standard position. And so if I look at this angle and I measure the rotation of my angle to the second ray, this second ray is what we call the terminal side. And so when I measure and I go in a counterclockwise direction, my angle measure is going to be positive. So this angle measure is going to be 150 degrees. But I could also measure it the other way. If I measure this angle back here, well, I know the whole thing has to add up to 360, so that must mean that this angle on the back side is going to be 210 degrees, because if I take 210 and add it to 150, I get 360. But because I went in a different direction, this is actually a negative 220 degrees, and that may not be something you're familiar with. So it turns out that a 150 degree angle is equivalent to a negative 210 degree angle, because they both share the same initial and terminal side. So when angles share the same terminal side, we call them coterminal angles. And actually, this is all in the notes above, so let me go ahead and finish filling them in. So let's see, the angle measure, we start here. So the angle measure is the amount of rotation between the two rays that form the angle. The rotation is measured from the initial side to what we call the terminal side of the angle. Positive angles are going to result from a counterclockwise rotation, and negative angles are going to result from a clockwise rotation. An angle with its initial side on the x-axis is said to be in standard position. So this angle, for example, is considered in standard position. So notice that we're giving the negative angle as negative 245. If I want to figure out the angle inside, I know it's going to be a positive angle because I'd be going in the counterclockwise direction. And if I want to figure out the measure of that, I'm just going to figure out the difference between 245 and 360. So we have a negative 245. If I add 360 to that, that's going to give me the interior angle, which is 115 degrees. And so we're given two examples. In example 1, it says, what are the two angles that both have the same terminal side in the circle below? So this is our initial side, and that's going to be in standard position. This is our terminal side. So the angle on the inside here is going to be a positive 90 degrees. If I want to find the other one, I'm just going to take 360 minus 90, and that's going to leave me with 270, and that makes, because I'd be going in the counterclockwise direction, that would be a negative 270 degrees. So it turns out a 90-degree angle is equivalent to a negative 270-degree angle. We can also have angles that are more than 360. And so if you take a look at number 2, it says if an angle measures 390 degrees, where does the terminal side lie? So since this is a positive value, I'm going to go counterclockwise. So here's my initial side. Sorry, my board's not calibrated anymore. So if I go counterclockwise, I'm going to go all the way around once is 360. If I need to go 390, that means I need to go another 30 degrees. So that puts my terminal angle my terminal side right there in the first quadrant. And if I think about it, if it would be equivalent, since I've already gone around 360, this degree measure then is just another 30 degrees. So it turns out that a 390 degree angle is equivalent to a 30 degree angle. And so when I talk about angles in standard form, I want to make sure that their degree measures are always between 0 and 360. So if I have a negative angle, I'm going to want to add 360 to it to get it into standard form. If my angle is more than 360, then I want to subtract 360 to get it in standard form. So what I mean by that is if I have an angle that measures, I don't know, let's say 452 degrees, that is not in standard form because it's beyond one full rotation around the circle. So what I'll do is I'll subtract 360, and let's see, 452 minus 360 is going to give us a 92 degree angle. So it turns out that a 452 degree angle is equivalent to a 92 degree angle. If I had a negative 60 degree angle, well, again, that is not in standard form. I need to add 360 to get it in standard form so it's within one full rotation on my unit circle. And so when I do that, I get 300 degrees. So it turns out a negative 60 degree angle is equivalent to a 300 degree angle. Okay. Well, let's talk about what a radian is and relate radians to degrees. So there's an activity that we did in class that you can't see because I don't have a video camera, but I want you to imagine that I'm standing in the middle. I'm standing in the middle here. And instead of having a student walk in a straight line across from me, I'm going to have a student walk, I'm going to have them stand, actually let me do this over here. I'm going to have them stand 1 meter away, and I'm going to have them do one complete rotation all the way around me. Okay, and so I know that if I were to do the whole exorcist thing and watch the student walk, the tilt of my head all the way around is going to correspond to 360 degrees. Well, the distance traveled by the student is going to just correspond to the circumference of the circle. So if we think about circumference of the circle, circumference is equal to 2 pi r. Well, if the student is 1 meter or 1 unit away from me, that means that he traveled a distance of 2 pi. Okay, and so that basically means that 360 degrees is equivalent to 2 pi. Well, what about if we're only talking about half the circle? So my terminal side would be here. So that would correspond to a 180 degree angle. And instead of being 2 pi, it's going to be half that. It's going to be pi. So these two formulas relate degrees and radians. So pi, we know that it's 3.14, but in terms of degrees, pi is equivalent to 180 degrees. And that enables us to come up with some conversions. So for example, a 90-degree angle. If I look at a 90-degree angle here, so I know that this is 90 degrees. If I want to relate it to radians, well, I know if half of the circle is pi, then half of that is going to be pi over 2. So it turns out that a 90-degree angle is going to be equivalent to pi over 2. So what about if I just wanted to figure out what a 1-degree angle is, or what 1 radian is? So we can actually do a quick conversion. If I know that 180 degrees is equal to pi radians, then I can actually solve for 1 degree. So if I want to figure out what 1 degree is equivalent to, I'm simply going to divide both sides by 180. And so when I do that, I'm going to have 1 degree is equal to pi over 180 radians. And pi over 180 is equivalent to 1 because pi and 180 are equivalent. I could also go the other way. If I want to figure out what 1 radian is worth, again, I'm going to start off with the same relationship. I know that 180 degrees is equivalent to pi radians. And if I want to solve for 1 radian, I'm just going to divide both sides by pi. And so I get 180 over pi degrees is equivalent to, those are going to cancel, 1 radian. And this is the conversion that you will use when you want to switch degrees to radians and radians to degrees. Okay, and I'll go through that in just a second. So angles can also be measured in radians. So we can measure them in degrees or radians. Either one is fine. With radians, you're always going to see, I shouldn't say you're always going to see, but you usually see a pi. So when you're doing your calculations, you're actually going to leave the pi out and leave your answer with a pi in it instead of writing it as a decimal. 1 radian is the angle made at the center of the circle by an arc whose length is equal to the radius of the circle. Radians also measure the distance traveled on the circle, so it relates to the circumference. The variable that we use to describe the measure of an angle, so we're used to talking about x and y. When we were talking about the normal distribution, remember we started talking about the mean and standard deviation, and we used the variables mu for mean and sigma for standard deviation. Well, when we're dealing with geometry or trigonometry, we use a different variable to represent angles, and we call it theta. It's another Greek letter, and theta looks like a big O with a line straight through it. We know that the circumference of a circle is going to be equal to 2 pi times the radius. In a unit circle, that would just be 2 pi radians. Okay, to fill in the rest of it, we know that 2 pi radians is equal to 360 degrees. So that's also saying that pi radians is equal to 180 degrees. And using the conversions that we did before, if we go back, we know that 1 radian is equivalent to 180 over pi degrees. And so 1 degree is going to be equivalent to pi over 180 radians. So if I want to convert degrees to radians, so for example, if I wanted to convert 180 degrees into radians, notice that when I am dealing with degrees, I don't have a pi. If I want to turn it into radians, I need a pi, so I'm going to multiply by the fraction that has the pi on top. And then I know that the 180s are going to cancel, and I'll just be left with pi. If I want to convert from radians to degrees, that means I have a pi, and I want to get rid of it. So I'm going to multiply by the fraction that has the pi in the denominator. So let me show you what I mean by that. We're given some examples of angles that are measured in degrees. The first thing I want to look at is make sure that my angles are in standard form, which means that my angles have to measure between 0 and 360. So if I take a look at number 3, I have an angle measure of 255. I know that's fine. Since it's measured in degrees, if I want to turn it into radians, that means that I need to multiply by something that's going to give it a pi. So I want to make sure that I'm multiplying by the fraction that has the pi on top. Because remember, pi over 180 is equivalent to 1. Pi and 180 degrees are equivalent. I am going to recommend when you're using the fractions that you write them vertically and not diagonally. So for example, I know a lot of you might want to write it like that, which is technically fine. But because we're going to be doing a lot of operations with fractions, it's going to help you to make sure that you can see the numerator and the denominator very distinctly. So I would recommend writing them vertically instead of as a diagonal like that. So now what I want to do is simplify this. If you think about multiplying a number times a fraction, if you think about it, 255, I can write it as a fraction just by putting a 1 underneath it. I am going to leave the pi out of my calculations because I don't want to have any nasty decimals. I want it to be as perfect and exact as possible. So essentially, anything on top of my fraction I'm multiplying, anything that's in the denominator I'm going to be dividing. So essentially, this is the same thing if I were to multiply through as 255 over 180 pi. And so if I take my calculator and I do 255 divided by 180, I'm going to get a nasty decimal. To fix that, I'm going to go to my math menu. I'm going to choose fraction, and I'm going to let my calculator rewrite that so it's in lowest terms. And so this is equivalent to 17 over 12 pi. I also would recommend that instead of using mixed numbers, you keep the pi in the numerator. So the way I would write my answer is 17 pi over 12. So in number 4, we've got 15 degrees. If I want to convert that to radians, that means I need to multiply by a fraction that has the pi on top. Well, since I've got the 15, that's just 15 over 1. I'm essentially taking 15 divided by 180 and then changing that into a fraction in lowest terms. And that's equivalent to 1 over 12. I don't want to forget about the pi, though, so it's going to be equivalent to pi over 12. Number 5, I have to be careful of because I'm dealing with a negative angle. So I need to correct it first. And to correct it, if I've got an angle that's less than 0, I need to add 360 to get it back on my unit circle, or back on my first rotation. So if I have negative 140 plus 360, that's going to be equivalent to a 220 degree angle. If I want to convert that into radians, then I also need to multiply by pi over 180. To simplify this, my 220 is in the numerator and the 180 is in the denominator, so I'm essentially taking 220 and dividing by 180 and then changing it back into a fraction in lowest terms. So this is going to be equivalent to 11 pi over 9. In number 6, again, we have to be careful because 390 is beyond one rotation on the unit circle, or on our circle. So in order to get it back down, I'm going to subtract 360. When I do that, I get a 30 degree angle. If I want to convert that into radians, I'm going to multiply by pi over 180. And again, I'm just going to take the 30 and divide it by 180 and then write it as a fraction in lowest terms. And so that's going to be equivalent to pi over 6. Okay? 720, I'm going to have to make it smaller. I'm sorry, 712. Okay, and that gives me 352. Sometimes our angles are so big that you might have to subtract 360 a couple of times, or maybe they're so small that you have to add 360 a couple of times. So like if you are, if you had an angle that was 1,000 degrees, you might have to subtract 360 2 or 3 times. When I multiply by pi over 180, again, the 180 is in the denominator, so I get 88 pi over 45. Don't worry if your fractions look kind of crazy. This one I'm going to add 360, so negative 325 plus 360. We get 35 degrees. When I multiply by pi over 180, I'm just going to divide by 180 and change it back into a fraction. Okay. The next section, we're going to go the other way. Now we're dealing with radians, and we want to convert to degrees. And so in this case, we're just going to work backwards. Since in these problems I have a pi, the goal is to get rid of pi and turn them into degrees. So if I have 2 pi over 3 and I want to get rid of the pi, that means I'm going to be multiplying by the fraction that has the pi in the denominator. That way the pi's cancel. And so now, if you look at your fractions, I'm just going to follow the order of operations. I can do 2 times 180 and divide it by 3. You can do it all in one step. Anything on top is going to get multiplied. Anything in the denominator, you're going to divide. And that gives me 120, and that's going to be 120 degrees. I can do the same thing for the next one. 5 pi over 6. I'm going to multiply by 180 over pi. My pi's cancel. We've got 5 times 180 divided by 6, and that gives me 150 degrees. Okay, 9 pi over 4, same thing. The pi's cancel. We've got 9 times 180 divided by 4. And notice this time my angle is 405 degrees. One of the criteria is that all of your angles are in standard form. And so 405 degrees is too big. I have to subtract 360 to get it back on one rotation of my circle. And so that means it is equivalent to a 45-degree angle. Number 13, we're dealing with a negative radians. So we know that every circle is going to be equivalent to 2 pi radians. So when we're dealing in radians, we want to make sure that our radian measures are between 0 and 2 pi. It's easier, though, if you convert it to degrees and then either add or subtract 360. So in this case, I'm going to keep the negative. So I have negative 2 pi over 3. I'm going to multiply that by 180 over pi. My pi's are going to cancel. When I multiply, I'm going to include the negative. So negative 2 times 180 divided by 3. And that's going to give me a negative 120-degree angle. I'm not allowed to leave my answer like that. Since it's negative, I'm going to add 360. And that leaves me with a 240-degree angle. Okay? I'm going to go ahead and let you do 14 and 15. If you could go ahead and pause the video. Okay, so I went ahead and did number 14. You end up with a negative 900-degree angle, so you have to keep adding 360 degrees until you get between 0 and 360. Number 15 is the same way, so I just multiplied through and I got negative 1350. So I'm just going to keep adding 360 until I find myself back with a number that is between 0 and 360. So I'm just going to keep adding until I get there. And so that's going to be equivalent to a 90-degree angle. All right. The last part that we're going to talk about has to do with arc length. The arc length is basically a measure of a fraction of a circle. So if I have a circle here and I create a sector like that, then the distance here is what I would call the arc length. An arc length is simply a fraction of the circumference of a circle. The formula for arc length, and it's funny because the variable that we use to represent arc length is actually an s, which doesn't make a lot of sense, but arc length, if we use the variable s to measure arc length, is simply going to be the measure of our angle theta times the radius of the circle. The catch is that theta must be measured in radians. Okay, so in order to use that formula, I need to make sure that I'm measuring in radians. I'm going to skip these examples and just jump right to the next set of problems. So we said that arc length is equal to theta times r, where theta is measured in radians. And r, again, is our radius, and s is our arc length. Okay, so if I take a look at number 16, if I want to find the arc length of a sector that has this information, I know that s is going to equal theta. Notice how theta is measured in radians. Now you may not always see the word radians next to the angle measure, but if you see a pi, that's sort of the giveaway that it's measured in radians. So it's in radians, so I don't need to change anything. And I know the radius is 12, and so if I multiply, remember 12 is just over 1, it's a whole number. So this is going to be equivalent to 6 pi. Now since I'm measuring a distance, I also want to make sure that I use units. If we take a look at number 17, we're given the radius, but notice that theta is not measured in radians. That means I have to change it. And in order to get it into radians, I need a pi. That means I'm going to multiply by the fraction that has the pi on top. And so I'm going to take 240, and I'm going to divide it by 180. And whoops, I need to change it into a fraction. And so I know that 240 degrees is equivalent to 4 pi over 3. Now I can plug that into my formula. So I know that arc length is going to be 4 pi over 3 times 5. And I can put that 5 over 1. And if I multiply through, that's going to give me 20 pi over 3. And that's going to be measured in feet. In number 18, I have to be careful because I'm not given the radius, I'm given the diameter. That means that my radius is going to be half of that, or 9 inches. And notice again, theta is not measured in radians, so I have to change it. And 30 divided by 180. Oops, I keep forgetting to change it to a fraction. Is going to be 1/6, or pi over 6. So if I want to find the arc length, I'm going to take pi over 6 times 9, and that's going to be 9 over 1. Well, 9/6 is going to reduce to 3/2, or 3 pi over 2, and I want to make sure I include inches. So sometimes you're going to have to solve for something. So for example, I'm just going to throw some other examples up here. Let's say I give you the arc length. I'm just going to make something up. Let's say I give you an arc length of, I don't know, 5 pi over 6, and I'm going to go ahead and use inches. And let's say that the radius is, I don't know, 3 inches. So I want to find theta. Okay, so I know that this is S. I know in my formula that S is equal to theta times R. And so if I plug in what I know that S is 5 pi over 6. I don't know theta, but I do know that R is equal to 3. So if I want to solve this equation, I need to divide both sides by 3, and that'll give me the value of theta. One of the things that you're going to have to remember with fractions, or when we're dealing with fractions, is that dividing by a number is the same as multiplying by its reciprocal. Because if I'm dealing with fractions, I don't want to take 5 pi over 6 and then divide that by 3. That'll be a little confusing. But 3 times 1/3 I know is going to eliminate the 3 from the right side of the equation. And now if I'm multiplying fractions, it's a little bit easier because I just multiply the top and I multiply by the numbers on the bottom, my denominators, and I get 18. So I know that theta is equal to 5 pi over 18. Well, what about if I told you that the arc length, let's say is, I don't know, let's say it's 9 pi over 4. Let's say theta is 30 degrees, and I want to find the value of R. So I have to be careful because, again, theta, in order for me to plug it into my formula, has to be measured in radians. So I'm going to need to multiply by pi over 180. And 30 over 180, we already did this one, is going to be pi over 6. And so if I know, again, that S is equal to theta times R, if I plug in what I know, 9 pi over 4 is equivalent to pi over 6 times R. And if I'm trying to solve for R, then I need to get rid of the pi over 6. So I can divide both sides by pi over 6, or I can remember that when I divide by a fraction, it's the same as multiplying by the reciprocal. And so the pi's are going to cancel, the 6's are going to cancel. So I'm just going to be left with the radius. And then if I look at the left-hand side, I can go ahead and simplify. I know my pi's are going to cancel. And I'm basically taking 6 times 9 and dividing by 4. And that gives me 13.5. I didn't put any units, but let's say I'm using centimeters. And that would make this 13.5 centimeters. What about if I asked, well, what's the diameter? Well, I would just double that. And so if I multiply by 2, I get 27. And again, that would be in centimeters. Okay? So today, let's just go ahead and wrap this up. To convert from degrees to radians, so remember, if I have degrees and I want radians, that means I need a pi. So I'm going to multiply by pi over 180. If I want to go the other way, I'm going to multiply by 180 over pi because I need to get rid of the pi. The formula used to calculate arc length is just going to be S equals theta times R, but you got to remember that theta must be in radians. All right, I hope that was helpful.